The story of NASA's Langley Research Center is the story of taking what seems impossible and making it reality. It began just 14 years after the Wright brothers achieved the elusive, some said preposterous, goal of powered flight, a goal chased by humankind for millennia. Their 120-foot journey at Kitty Hawk, North Carolina in 1903 broke the impossibility barrier, setting the course for the next century and beyond. The United States invented the first successful airplane, but European countries brought aviation to new heights. From the start, a number of European governments funded aeronautics research, which paid off when World War I broke out in 1914. Even before the war, aviation leaders realized the U.S. was falling behind and pressed Washington to do something about it. So in 1915, Congress authorized $5,000 to create the National Advisory Committee for Aeronautics, the NACA. This little seed, planted in the fertile farmland of Hampton, Virginia in 1917, grew to become NASA Langley, America's first civilian aeronautics research lab and NASA's first center. And it's been reaching for the impossible ever since.
To go to the moon in this decade, not because they are easy, but because they are hard.
The National Advisory Committee for Aeronautics facility began as administrative offices and a wind tunnel building on rural land that the U.S. Air Service wasn't using. The NACA broke ground for the Langley Memorial Aeronautical Laboratory on July 17, 1917. Topographically, it was a swamp, but geographically, it was ideal.
Hampton was really the perfect area for a facility like Langley. The U.S. Army Air Service was already there, so there was already flying going on. And what the engineers liked was the fact that it was a pretty good distance from Washington. So the suits were up there and the engineers had Langley to themselves.
World War I had shown aircraft's need for more speed, power, and agility. Not just in wartime, but for untapped commercial possibilities. It was for that reason Langley was conceived as a truly national laboratory, to benefit aeronautical exploration. From the start, Langley dedicated itself to building the tools, setting the rules, and solving the problems that kept flight from reaching its potential.
At the time Langley was established, the potential for aeronautics was as big as the sky. There was no place to go literally but up. The United States was really far behind Europe in terms of aeronautical research and progress. The Europeans, after all, had been driven by the fear of war and then an actual war, lots of money going into the technology. In this country, not so much. And the founders of the NACA recognized just how important those European labs had been in pushing European aeronautics.
Langley came online as America's first civilian aeronautical research lab in 1920. The NACA's first atmospheric wind tunnel was already at work testing aerodynamic forces that affect aircraft. It was a good beginning, but by no means state of the art. The aerodynamicists knew they needed to do better, a lot better. And they did. 2 years later, in 1922, they powered up a new device no one had ever seen before. The world's first pressurized wind tunnel, the Variable Density Tunnel.
One of the things they did with it early on was to run a whole string of airfoil tests, just all kinds of airfoil shapes. And they published the data in kind of a catalog that was really of revolutionary importance for airplane designers. You could go to the NACA catalog, you could pick out an airfoil that had the characteristics you wanted, and there you go.
These reports, still used by aircraft designers today, kicked off Langley's reputation as a preeminent research facility. The value of Langley's wind tunnels came early. In 1928, Langley engineer Fred Weick used the propeller research tunnel to design a cowling, or cover, for propeller engines that reduced drag, cooled the engine, and increased an aircraft's flight speed.
And it was those sorts of improvements coming out of the NACA that really laid the foundation for the advance of both military and commercial aviation in this country.
Success followed success. Encouraged by the propeller research tunnel, which was big enough for a full-size aircraft minus the wings, Langley built a tunnel to test entire planes, wings and all. In 1931, Langley opened the full-scale tunnel, which could test at speeds up to 118 miles per hour.
You really can't talk about the history of aeronautical research at Langley without talking about those wind tunnels. As you get into the mid and late 1930s, Langley, on the basis of the airfoil research, the cowling, and all of the other work they were doing, had established itself, the engineers had established themselves as a match for anybody else in the world. The Germans, the English, Langley was right there contributing to the body of knowledge.
And when the winds of war began to blow, Langley's tunnels were ready to serve. Many believed we would never beat Germany's superior air power. And based on how things looked at the end of World War I, that would be a reasonable assumption. But a lot had changed in one generation.
During the war, I think the lights never went out at Langley Research Center. The full-scale tunnel, I mean, you could put a full-scale fighter with a 40-foot wingspan in that tunnel and do really important tests with it.